know how to find possible roots, we're going to talk about how to find all actual roots. So the first step is to find the possible roots, and then we're going to test them and see if they work. So here we have our leading term is 3, which the factors of the leading term would be plus or minus 3 and plus or minus 1. And then we have our constant term, which is 5. So our factors would be plus or minus 5 and plus or minus 1. And we want to look at all combinations of plus or minus p over q, where p is the factors of our constant term and q are the factors of our leading term. So plus or minus p over your q, we get 5 over 3 plus or minus, and 5 over 1 plus or minus. We get 1 over 3 plus or minus, and 1 over 1 plus or minus. And that's all 4 combinations, which turns out to be 8 possible solutions. And when you simplify that, you get plus or minus 5/3, plus or minus 5, plus or minus 1/3, and plus or minus 1. All right, and now we're going to look at these roots and test them to see if they work. So we can test them to see if they're roots, because if they're roots, they would have a remainder of 0 using the remainder theorem. So it is a root if the remainder equals 0. So if we plug one of these in, I'm going to start with -1, and you can just pick one at random and plug it in using synthetic division. And we set up our synthetic division to match the coefficients of our polynomial. We bring down the first term, multiply, -1 times 3 is -3, add down, -1 times -13 is positive 13, add down, -1 times -11 is positive 11, add down, -5, add down, you get a remainder of 0. So, yes, -1 is a root. So that is an actual solution. Now, let's look at one that might not work. So I'm going to try 5/3 here. And again, you set up the same thing using the coefficients on your polynomial. Bring the first term down. 5/3 times 3 is 5. Add down, -5. 5/3 times -5 is -25/3. Add down, get -97/3. Multiply 5/3 times -97/3 would be -539/9. As you can see, it's starting to get a little messy. Actually, sorry, this is 485/9. And you add down and you get -539/9. And when you multiply here, you get -2695/27. You add down and you get obviously not a remainder of 0. So this would not be a root. Now, you would continue going through all 8 of these until you test to see whether they either do work or do not work. However, we know since the degree is 4, this is going to have the maximum of 4 roots. So if you get up to 4, then you know you can stop there after you find 4 roots that work. Otherwise, you would just test all 8 until you see how many of those roots do work. And we'll talk about in a future video, after you understand how this works and why it works, a shortcut that we can use. But for now, we'll just give you some nice, easy problems with a few less steps and something not this crazy for you to practice.